Alright, so we are picking up with the next section in chapter 5, which is simplifying radicals and complex numbers. So what we're going to do today is investigate perfect squares. We're going to investigate square roots, and then our goal for today and Monday is to simplify square roots. So in the past I've said, if it's not a perfect square, just leave it as is. Well, now we're going to say if it's not a perfect square, we're not going to quite leave it as is. We're maybe going to simplify it down into its perfect squares and non-perfect squares. So we are going to simply simplify. Simplify does not mean decimals. So simplify does not mean decimals. So I don't want decimal approximation. I want an exact or equivalent equation. So in order to be successful, we need to know our first 15 perfect squares. So again, we need to know these. First time, second time, third time, maybe it takes you a minute to memorize. By the end of Monday, I would assume we will just know them. We're going to use them so frequently. 1 squared is 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is the reverse of those last numbers. It's 196. And 15 squared is 225. So we are going to be looking for numbers that are either these numbers in red or divisible by those numbers in red. What is an nth root? An nth root is any number raised to that power. The most common root we look at or investigate is a square root. The most common one we look at or investigate is a square root. The symbol used to indicate a root is the square root symbol. To make it the nth root, we treat it like there is a letter N there. So in a cube root, which I'm sure you've heard before, that n is equal to 3. In a square root, that n is equal to 2, hence square. A fourth root, the n would be equal to 4. A radicand is what we talk about is under the radical. So a radicand is what's under the radical. A radicand is what's under a radical. The square root of a number, if b squared is equal to a, then we say that b is a square root of a. B squared is equal to a, then b is a square root of a. That's what it would look like algebraically. all square roots are considered to be inherently positive unless they have a symbol or an equation with them. All square roots are inherently positive unless they have a symbol in front of them. So an example of a positive square root would be like the square root of 16. And again, we know that 16 is a perfect square, so that becomes 4. A negative square root of a maybe non-perfect square could look like negative the square root of 17. So that's something where we don't need to simplify it. 17 is prime, but it's negative. The negative can be outside a square root. It cannot be in the square root. So negative can be outside, but not in. And then you can have a positive and negative square root. So you could have plus or minus the square root of 19, or again, that cannot be simplified. Or you could have plus or minus the square root of 36, which is equal to plus or minus 6. And then we do simplify. Thanks, guys. A radical symbol indicates a square root. The radical symbol indicates a square root. So we can say that the square root of x squared is really like x squared to the 1/2 power. And that's why a square root of something squared becomes that absolute value of that something. So again, all square roots are inherently positive unless there is a negative in front. Unless there is a negative in front. We use the property of multiplication and division to simplify square roots. We're going to use the properties of multiplication and division to simplify square roots. They can be used interchangeably, meaning you can take two numbers multiplied together to get a bigger number, or you can take one big number and break it down into two smaller numbers. Give you a minute to copy that down. Let's apply those properties and simplify some examples. The square root of 25. If you look at your perfect squares, 25 is a perfect square. It is equal to or the same as the square root of 5 squared. And we just said that a square root and a square cancel each other. So if a number can be rewritten as a number squared, then that makes it a perfect square. Square roots and square cancel each other. So the square root of 25 is 5. The square root of 25 is 5. If you actually type that one in on your calculator, it would give you 5. 7. 7 is what we call a prime number. Prime numbers have no factors or multiples except for themselves and 1. So it can't be itself squared. Therefore, something like the square root of 7 is simplified completely. It cannot be simplified any further. And again, could you take the square root of 7? Yes. Are you going to get a decimal? Yes. Do I want decimals? No. I'm assuming the square root of 7 is something like 2.6, 2.7, but I don't want that as a value. I only want simplified perfect numbers. Okay, negative 144. Well, 144 is a perfect square. That is the same as negative square root of 12 squared. So again, perfect square inside cancels that square root. So negative 144 is really negative 12. If it has a negative or a plus or minus in front, that stays. 9 is a perfect square. 9 becomes plus or minus 3. You don't need to show me the steps where you write 9 as the perfect square, 3 squared. If it helps you, great, then you can do it. But if you know the square root of 9 is 3, you do not need to show me this. Does that make sense? If you can go from here to there, great. If you need this middle step, that's fine too. 121, perfect square. Square root of 121 is 11. So you get plus or minus 11. The rule for division is that you can think of them as separate problems. So you can think of this as the square root of 25 over the square root of 81. So then you look at them as individuals and you say, oh, well, 25 is a perfect square, so I can simplify that. 81 is a perfect square, so I can simplify that. And we say that the square root of 25 over 81 is equal to 5/9. Those are the easy ones. What happens if the number is not prime and it's not a perfect square? So now we have cases where numbers are not prime, meaning they have factors, but they're also not perfect squares. So the number 147 can be broken up into 2 other numbers. And when you break that number up, you want to break it up into a number that is a perfect square and a number that is not a perfect square. So what you're going to do is take 147 and start dividing it by the perfect squares. When you divide it by perfect squares, you want to start at the highest perfect square, not the lowest. So if I go back to my table of perfect squares, I'm going to start taking 147 and dividing it by numbers smaller than itself. Is 147 going to divide by 144? No. So you don't have to bother dividing it by numbers that don't make sense. Does 147 divide by 121? Oh, again, it's still too big. Does 147 divide by 100? Oh. So now maybe I start with 81 and I say, okay, 147 divided by 81. No, that's a decimal. Doesn't work. 147 divided by 64. Decimal. Doesn't work. 147 divided by 49. It's 3. It works. I'm happy. I rewrite 147 as 49 and 3. Why do I want to write it as 49 and 3? What's the square root of 49? 7. So I can rewrite square root of 147 as 7 square roots of 3. That helps me know that this number is somewhere near 12. 7 times something smaller than 3. Okay? 605. Find the perfect square that divides into 605. Here's a hint. All numbers that end in 5 and 0 divide by 5. Good job. So take 605, divide by 5. That's where I would start, just to give myself an idea. When you take 605 and divide by 5, what do you get? 121. What's 121? A perfect square. I'll quite get 11. Yes. So the square root of 605 then becomes square roots of 5. Not quite just 11. Whatever's the perfect square comes out of the square root. Whatever's not the perfect square stays in. Does that make sense? That's like the big mistake I feel like people make. A lot of times people give me square root of 11 and then they take out the 5. And I'm like, no, that's backwards. Okay, 2 square roots of 50. The 2 doesn't affect what we're doing. You kind of ignore it. 50 breaks down into what 2 numbers where one of them is a perfect square? Don't tell me 5 and 10 because 5 and 10 aren't perfect squares. I want a perfect square that goes into 50. What? Yeah, 25. So 50 becomes 2. The 2 tags along. It doesn't go away. Square roots of 25. Square roots of 2. 25 times 2 is 50. We're happy. What's the square root of 25? Very good. It's 5, right? So now what you do is that 2 stays. The square root of 25 becomes 5. Square root of 2 stays. But this is just like normal math. 2 times 5 is 10. So that becomes 10 square roots of 2. Everybody following me okay? All right. I'm sick of red. Let's go to blue. If you have two square roots being multiplied together, my suggestion is to multiply the numbers together to get a bigger number. Not to try to get smaller numbers now, because then you end up not simplifying it all the way. So what is 40 times 5? 200. What really nice perfect square is going to go into 200? 100. So that becomes the square root of 100 times the square root of 2. The square root of 100 is 10. Thank you. So we get 10 square roots of 2. If you had tried to do it the other way, you'd have like broken 40 down into like 8 and 5. Then you'd have broken 8 down into 4 and 2. You'd have had all these like numbers jumbled, and you would have to have found like all the tiny perfect squares. So it's easier to multiply them together, get a big number, and simplify it. What happens in letter K? You have root 12 times root 12. You have the same number times the same number. Anytime you have two of the same roots times each other, the square roots go away. So again, square root of 12 times square root of 12, the square root goes away and you are left with 12. The reason for that is because if you multiply 12 and 12 together, you get 144, and we know that the square root of 144 is 12. Once again, multiply the square roots together. The 2 does not multiply to the 6 and the 18. The 2 does not multiply to the 6 and the 18. It's on the outside of the square root. So it is not friends with my square root. It tags along. 6 times 18 is... Excellent. Now, again, everybody knows 108 is 9 times 12. And you don't, but you should. 9 is a perfect square. And you're like, yes, I'm going to simplify it. But then what happens? 12 also divides by a perfect square. Divides by 4. So 9 and 12 are not the best numbers to break this down into. Instead of 9 and 12, what bigger perfect square should I divide 108 by?
12.
12 is not a perfect square, so I don't want to use 12. Yeah, 36. So remember, you only want to divide by your perfect squares, and you want to start with the biggest and go down, not the smallest and go up. So everybody makes the mistake of. So I get 12 square roots of 3. Your homework is only the front of that next page. 124 only. Don't worry about that. It is the front of that next page. Deal? Yes.